All right, so we are starting on page 214. That's where we left off. Unfortunately, my last video was the audio was messed up by OBS. It got stuck on stop recording, and once I forced the video to stop, the audio came out completely messed up. So hopefully this is not gonna happen this time. So let's get going. Uh, okay, so we left on applying interfaces. I need to. Okay. All right, applying interfaces. To understand the power of interfaces, let's look at a more practical example. In earlier chapters, you developed a class called stack that implemented a simple fixed size stack. However, there are many ways to implement a stack. For example, that stack can be of a fixed size or it can be growable. The stack can also be held in an array, a linked list, a binary tree, and so on. No matter how the stack is implemented, the interface of the stack remains the same. That is, the methods push and pop define the interface of the stack independently of the details of the implementation. Because the interface of the stack is separate from its implementation, and it's easy to define a stack interface. The specific. Let's look at examples. First, here's the interface that defines an integer stack, but this in a file called instack.java. This interface will be used by both stack implementations. All right. Okay. I have to do something here briefly. All right, and now let me just, okay. All right, we're good to go. Okay, you can stop the video to your convenience to look at that because I'm already familiar with the subject. Following program creates a stack called fixed stack. It implements a fixed length version of an integer stack. All right, implements in stack. Okay, so this is the interface. Push, store an item, int pop, retrieve an item. All right, int stack to us. All right, so here we have void the return type. Okay. Okay. Here we an array stack. Okay. Locating and initializing stack fixed stack in size. All right. No int size. Okay. Size is fixed stack. Okay. Okay. Class if test object. Okay. My stack. Okay. Okay. Yeah. Okay, following is another implementation of instack that creates a dynamic stack by use of the same interface definition. In this implementation, each stack is constructed with an initial length, and this initial length is exceeded, then the stack is increased in size. Each time more room is needed, the size of the stack is doubled. Now, this one is an implementation that I want to see. Okay, implements growable stack. Dynamic stack implements in stack. Okay, allocate initialize an initialize stack. Okay. Now let's bring this up a little bit. Push a 19 into stack. If stack is full, allocate a larger stack. So if top of stack equals stack that length, int temp new stack length 2. Yeah. Excuse me. Well, I knew that much. Double size for int length temp I. Okay, stack I. basically copy the whole stack. Okay, stack equals temp. Okay, put the item in the next index. Plus plus increase the index, then the stack. Yeah. So basically, you're creating a new one is what it is. Okay. 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 Yeah, because it's multiplying if it doesn't have anything. All right. You can pause the video if you want to see more. Final class updates both the fit stack and then stack implementations. It does so through an interface reference. This means that calls to push and pop are resolved at runtime rather than at compile time. Okay. Stack, okay. Fix stack. Okay, so the interface is called, first the interface, let's go up. Int stack is the interface, all right. Where is the interface variable? Oh, here, int stack, my stack. So this is the interface variable right here. Okay. But it's not being used here. Where is it? Oh, my stack right there. Load fix stack, yeah. Yeah. And then load the dynamic stack down there. Fix stack again. Yeah. Okay. In this program, my stack is a reference to the in-stack interface. Thus, when it refers to DS, it uses the versions of push and pop defined by dynamic stack implementation. When it refers to FS, it uses the versions of open stack, pushes and pop defined by fixed stack. As explained, these determinations are made at runtime. Accessing multiple implementations of an interface through an interface reference variables is the most powerful way that Java achieves runtime polymorphism. Yeah, this is good actually. This is good. Variables in interfaces. You can use interfaces to import shared constant into multiple classes by simply declaring an interface that contains variables that are initialized to the desired values. Okay. When you include that interface in a class, that is, when you implement the interface, all those variable names will be in scope as constants. In an interface, if an interface contains no methods, then any class that includes such an interface doesn't actually implement anything. It is as if that class were importing the constant fields into the class namespace as final variables. The next example uses this technique to implement an automated decision maker. Oh, oof. Okay, let's see. Java util random. Okay, the random class. Interface share constants. Okay, int no, int yes, int maybe, int later, soon, never. I like that. Class question implements share constants. Int ask. Random, new random. The random produces pseudo random numbers. Random numbers. Okay. int 100 times around the next double. If prop less than 30, return no. Else if prop less than 60, return yes. Okay. Else if prop less than 75, return later. Else if prop less than 98, return soon. Okay. Else return never. Okay, where is the ask? Okay, ask is the answer. Ask me. Share contact, static void answer. Okay. And result, switch result. Switch result. Case no. Right. Case yes. System printout. Yes. Right. Okay. Later. Hmm. All right. So maybe it's right there. Okay. Maybe it's not used here. But it's used here. Okay. So now the next one. Void main question, a question, answer, the ask. That's pretty good. Answer is um the method from ask me, and the switch is part of the uh, mechanics that it uses to answer. But it's being fed in this in here. It's being fed the ask method here. Okay. Just that the okay, no, it does not take. It uses the random to just generate a response. That's what it is. And it uses the percentages here to tell it how often it should generate those responses. Basically, that's pretty smart. That's pretty smart. Okay. Public static void main question no question. That's pretty good. Notice that this program is use of one of Java standard classes random. This class provides pseudo-random numbers. It contains several methods that allow you to obtain random numbers in the form required by your program. In this example, the method next double is used. It returns random numbers in the range of 0 to 1. In this program, these two classes, question and ask me, both implement the share constants interface where no, yes, maybe, soon, later, and never are defined. Inside each class, the code refers to these constants as which class had defined or inherited them directly. Yeah. Here is the output of a sample run of this program. Note that the results are different each time it runs. Yeah. Yeah, that's pretty good. So share constants, share constants. Okay. Yeah. Later, soon, no, yes. The technique of using an interface to define shared constants, as just described, is controversial. It is described here for completeness. Yeah, okay. Interfaces can be extended. One interface can inherit another by use of the keyword extends. The syntax is the same as for inheriting classes. When a class implements an interface that inherits another interface, it must provide implementations for all methods required by the interface inheritance chain. Following is an example. one interface can extend another. Interface A, void meth1, void meth2. And another is by use of the keyword extend. The syntax is the same as for inheriting classes. When a class implements an interface that inherits another interface, it must provide implementations for all methods required by the interface inheritance chain. Interface A, method 1, 2. By now, B now includes method 1, method 2. It adds method 3. Interface B extends A. Void method 3. Okay. Yep. Another by use the keyword extends. Mm. All right. As an experiment, you may want to try removing the implementation for meth1 in my class. This will cause a compile time error. As stated earlier, any class that implements an interface must implement all methods required by that interface, including any that are inherited from other interfaces. All right. Default interface methods. Okay. So let's take a look at this. Default interface methods. Okay. It's going to be interesting. As explained earlier, prior to JDK8, an interface could not define any implementation whatsoever. This meant that for all previous versions of Java, the methods specified by an interface were abstract, containing no body. Excuse me, sorry. This is the traditional form of an interface and is the type of interface that the preceding discussions have used. The release of JDK8 changed this by adding a new capability to the interface called default method. A default method lets you define a default implementation for an interface method. In other words, by use of the default method, it is possible for an interface method to provide a body rather than being abstract. During its development, the default method was also referred to as an extension method, and you will likely see both terms used. The primary motivation for the default method was to provide a means by which interfaces could be expanded without breaking existing code. Oof. Okay. Recall that there must be implementations for all methods defined by an interface. In the past, if a new method were added to a popular, widely used interface, then the addition of that method will break existing code because no implementation will be found for that new method. Wow, now I get it. I can understand why Moshe Minada didn't like that, but at the same time, the addition of the default method, but I can understand now why it was added. It makes sense. It will break the whole chain of command, the whole chain of programming will break a program. So this was a way to add it without breaking a program and just adding a default method and then just using it whenever you needed to without having to go through all the classes. That makes absolute sense. Wow. Basically, this was just done to save old code repositories to keep them valid. That's that's all it is. But you shouldn't use it like that because that's the point is to use it in those special situations. And interface is not meant to implement anything. So the philosophy is still there. Okay. The default method shall describe by supplying an implementation that would be used if no other implementation is explicitly provided. Thus, the addition of a default method will not cause pre-existing code to break. Yeah. Wow. That makes sense. Now I get it. After motivation for the default method was the desire. I don't know. Another motivation for the default method was the desire to specify methods in an interface that are essentially optional depending on how the interface is used. For example, an interface might, oh wow, an optional interface. Well, that's a strange idea, but I can see how it expands the language and makes it more approachable, more accessible. It can adapt to so many other situations. I can see that. Well, it betters the language in a sense. As long as you remember the initial version for interfaces, it it's just good. Okay. For example, an interface might define a group of methods that act on a consequence on a no, excuse me, a group of methods that act on a sequence of elements. One of these methods might be called remove, and its purpose is to remove an element from the sequence. However, if the interface is extended to support both modifiable and non-modifiable sequences, then remove is essentially optional because it won't be used by non-modifiable sequences. Even though the interface itself is meant to support both modifiable and non-modifiable sequences, okay, by providing other members of the interface, right? That makes sense. In the past, a class that implemented a non-modifiable sequence will have had to define an empty implementation of remove, even though it was not intended. Yeah. So this way you only have one implementation and that's it. You don't have to add a second implementation to make it valid. Yeah, that curtails a lot of issues. I can understand that. Okay. Today, a default implementation of remove can be specified in an interface that does nothing or throws an exception. Writing this default prevents a class use for non-modifiable sequences from having to define its own placeholder version of remove. Yeah, yeah, it makes sense. Thus, by providing a default, the interface makes the implementation of remove by a class optional. Absolutely makes sense. It is important to point out that the addition of default methods does not change a key aspect of interface, its inability to maintain state information. Right. An interface still cannot have instance variables, for example. Thus, the defining difference between an interface and a class is that a class can maintain state information, but an interface cannot. Furthermore, it is still not possible to create an instance of an interface by itself. Mm-hmm. Yep. It must be implemented by a class. Therefore, even though beginning with JDK8, an interface can define default methods, the interface must still be implemented by a class even if an instance is to be created. Yeah, that completely makes sense. Okay, I understand the way that Mohamed had explained it, and I see that Herbert Schildt is making me completely understand why it was necessary and why it's okay. It's not meant to be used. It's meant to be used in all code. It's to save all code. And in these special situations that he's describing, it absolutely helps because then if you have like 10, 16, 80 classes that will have to have its own implementation of this code, you don't have to now because you can just have one default implementation in the interface. So absolutely a lifesaver. I can get it. I get it. I get it. Okay. Okay. One last point. As a general rule, default methods constitute a special purpose feature. Yep. It makes sense. Interfaces you create will still be used primarily to specify what and not how. However, the inclusion of the default method gives you added flexibility. Understood. It's just a lifesaver. Default method fundamentals. Okay. An interface default method is defined similar to the way a method is defined by a class. The primary difference is that the declaration is preceded by the keyword default. For example, consider the simple interface. Public interface myIf. This is a normal interface method declaration. It does not define a default implementation into getNumber. Now, this is a default method. Notice that it provides a default implementation. Default string, get string, return default string. Yeah, absolutely beautiful. That's brilliant. That's brilliant. I can understand the complaints against it, but I also understand the reason behind it, and the reason behind it can completely satisfy the situation. My if declares two methods. Excuse me. Oof. The first, getNumber, is a standard interface method declaration. It defines no implementation whatsoever. The second method is getString. and it does include a default implementation. In this case, it simply returns a string, default string. Pay special attention to the way getString is declared. Its declaration is preceded by the default modifier. This syntax can be generalized. To define a default method precedes its declaration with default. Default method precedes its declaration with default. Each is preceded by a default modifier. This syntax can be generalized. To define a default method precedes its declaration with default. Excuse me. All right. Okay, because getString includes a default implementation, it is not necessary for any implementing class to override it. In other words, if an implementing class does not provide its own implementation, the default is used. For example, my if implementation class shown next is perfectly valid. Okay, first, my if implements my if. Only get number defined by my if needs to be implemented. GetString can be allowed to default. Public int get number return 100. Yeah, because the default method is already implemented. It makes sense. This is beautiful. Wow. I like this very much. The following code creates an instance of, oh, excuse me, what is going on here? Okay, there we go. The following code creates an instance of my if imp and uses it to call both get number and get string. Okay, use the default method class my default method demo. My if imp object new my if imp call get number because it is explicitly implemented by int system get out get number. Can also call get string because of default implementation of system string. Yeah, it doesn't need to. This is beautiful. The output is shown here. Yep. This is really gorgeous. I like the idea. All right, as you can see, the default implementation of getString was automatically used. It was not necessary for. Oh, excuse me a second. Um, excuse me a second, guys. Excuse me a second. Uh, all right, never mind. Actually, let me see. All right. Okay. As you can see, the default implementation of getString was automatically added. It was not necessary for my aim to define it. Thus, for getString, implementation by class is optional. Of course, its implementation by class will be required if the class uses getString. For some purpose beyond that, supported by its default. Yeah, if it needs to be overloaded. It is both possible and common for an implementing class to define its own implementation of a default method. For example, my imp2 overrides getString. Okay, my if imp2 implements my if. Here, implementations for both get number and get string are provided. Get number string, okay. Oh, this one. Public string, get string. Return, this is a different string. Yeah. Oh, let me look at the original, my if, the default string. Okay, so the modifier is default. There is no public string. Okay, and then this one, excuse me. This is public. That's a modifier public. Access modifier string. All right. Now, with getString is called, a different string is returned. Very nice. But that's still the question still is whether that implementation of the second class is going to it's going to hide the original implementation, or if you can access both implementations. That's the question. In this case, the implementation is practically the signature is the same because it doesn't have, except for the public access, it doesn't have a parameter list. So it probably hides the original the default implementation. I'm guessing here. Okay, that's probably what's going to happen. All right, a more practical example. Okay, so a more practical example, although the preceding shows the mechanics of using default methods, it doesn't illustrate their usefulness in a more practical setting. To do this, let's once again return to the instack interface shown earlier in this chapter. For the sake of discussion, assume that instack is widely used as used and many programs rely on it. Further, assume that we now want to add a method to instack that clears the stack, enabling the stack to be reused. Thus, we want to evolve the instack interface so that it defines new functionality. But we don't want to break any pre-existing code. In the past, this will be impossible, but with the inclusion of default methods, it is now easy to do. Okay. All right. This is pretty good. Yeah, I completely get it, you know? I don't even have to see this. You may pause the videos you like. I'm going to continue moving forward. Okay, here the default behavior clear simply displays a message indicating that it is not implemented. This is acceptable because no pre-existing class that implements instack will ever call clear because it was not defined by the earlier version of instack. However, clear can be implemented by a new class that implements instack. Furthermore, clear is to be defined by a new implementation only if it is used. Thus, the default method gives you a way to gracefully evolve interfaces over time, a way to provide optional functionality without requiring that a class provide a placeholder implementation when that functionality is not needed. Yeah, yeah, absolutely love it. Another point, in real world code, clear will have thrown an exception rather than displaying an error message. Exceptions are described in the next chapter. After working through the material, you may want to try modifying clear so that its default implementation throws an unsupported operation exception. Yeah. Mm. What I don't understand is why, if you can handle and issue and throw a message, why would I want to throw an exception? What's for what? I mean, the user is not going to see that. We don't want a user to see that. What's the point? So, multiple inheritance issues. As explained earlier in this book, Java does not support the multiple inheritance of classes. Now that an interface can include default methods, you might be wondering if an interface can provide a way around this restriction. The answer is essentially no. Okay. Recall that there is still a key difference between a class and an interface. A class can maintain state information, especially through the use of instance variables, but an interface cannot. The preceding notwithstanding, default methods do offer a bit of what one would normally associate with the concept of multiple inheritance. For example, you might have a class that implements two interfaces. If each of these interfaces provides default methods, but then some behavior is inherited from both. Okay. Thus, to a limited extent, the default methods do support multiple inheritance of behavior. As you might guess, in such a situation, it is possible that a name conflict will occur. Yeah, I can understand the saving of state. Yeah. So For example, assume that two interfaces called alpha and beta are implemented by a class called myClass. What happens if both alpha and beta provide a method called reset, for which both declare a default implementation? Is the version by alpha or the version by beta used by myClass? Or consider a situation in which beta extends alpha. Which version of the default method is used? Or what if my class provides its own implementation of the method? To handle these and other similar types of situations, Java defines a set of rules that resolves such conflicts. First, in all cases, a class implementation takes priority over an interface default implementation. Okay, so it hides it. That answers my question from earlier. Thus, if my class provides an override default method, my class version is used. This is the case even if my class implements both alpha and beta. In this case, both defaults are overridden by my class implementation. Second, in cases in which a class implements two interfaces that both have the same default method, but the class does not override that method, then an error will result. Continue with the example. If my class implements both alpha and beta, but does not override reset, then an error will occur. In cases in which one interface inherits another, which both defining a common default method, the inheriting interface's version of the method takes precedence. So the second interface takes precedence. So it hides the original. Therefore, continuing the example, if beta extends alpha, then beta's version of reset will be used. It is possible to explicitly refer to a default implementation in an inherited interface by using this form of super. Okay, so same as before. Okay. Interface name super. Oh, excuse. Interface name super method name. For example, if beta wants to refer to alpha's default reset, it can use the statement alpha.super.reset. See, that's also pretty cool. Hey, that's a trick right there. That's something to remember. Use static methods in an interface. Another capability added to interface by JDK8 is the ability to define one or more static methods. Like, okay, this I need to know. Like static methods in a class, a static method defined by an interface can be called independently of any object. Thus, no implementation of the interface is necessary, and no instance of the interface is required. In order to call a static method, okay, the implementation of the interface is necessary, and no instance of the interface is required in order to call a static method. Yeah. Okay. A static method is always specified interface name followed by period followed by method. The method name is the form. Interface name static method name. That makes sense. Note that this is similar to the way that a static method in a class is called. Yeah, especially if it's not imported. Imported. The following shows an example of a static method in an interface by adding one to MYIF, shown in the previous section. The static method is get default number. It returns 0. Okay. All right. Excuse me. Interface my if int get number. This is a default method. Notice that it provides a default implementation. Default get string. This is a static interface method. Static int get default number return. That's pretty cool. It doesn't need. Okay, to get default number method, get default number method can be called as shown here. Int def number my if get default number. That's pretty cool. As mentioned, no implementation or instance of my if is required to call the default number because it is static. One last point. Static interface methods are not inherited by either an implementing class or a sub interface. They're not inherited. So they're global. They're global variables, global methods. That's pretty interesting. I mean, he's not saying it, but they're global. That probably means they can be using any class in the package because they're not inherited by an implementing class or sub interface. So they're not restricted to them. Okay, private interface methods. Okay. Beginning with JDK9, an interface can include private interface methods. Okay. A private interface method can be called only by a default method or another private method defined by the same interface. Well, that's a strange thing. A private interface method can be called only by a default method or another private method defined by the same interface. So basically, probably called in the body by using it in its body, I guess, in its implementation. I wonder. This interface method is specified by cannot use a code outside interface in which it's before. This section includes sub-interface because a private interface method is not inherited by a sub-interface. Okay, so static and privates are not inherited. Well, that's pretty cool. The key benefit of a private interface method is that it lets two or more default methods use a common piece of code, thus avoiding code duplication. Yeah. For example, here's another version of the instack interface that has two default methods called pop and elements and skip and pop and elements. The first returns an array that contains the top n elements on the stack. The second skips a specified number of elements and then returns an array that contains the next n elements. Oh, that is so, oof, that's an idea right there. I like this. Both use a private method called getElements to obtain an array of the specified number of elements from the stack. I like this. Let's say this implementation I'm going to read. Okay, another version of instack that has private interface method that is used by two default methods. Oh, excuse me. All right. That was another mosquito. All right. Into interface instack void push an item, store an item, in pop, retrieve an item. Okay. Default method that returns an array that contains the top n elements in the stack. Default int pop elements int return the requested elements, return get elements. And okay, a default method that returns an array that contains the next n elements of the stack after skipping elements. Okay, default int array. Okay, skip and pop elements, skip int and skip the specified number of elements, get elements, skip. Okay. Return the requested elements, return get elements. Okay. All right, so let's see. Let's go back. Push an item, okay. Return the requested elements, return get elements. Okay, so we got it. Where is the original get elements defined? Okay. The returns an array containing the top n elements of the stack. Oh, here it is. Okay. Private method that returns an array containing the top n elements on the stack. Private int get element int elements, no int Okay, so create array for int elements less than n, right? Okay, which is the length basically. Elements I pop, just remove them. Return elements. Okay, so now here, let's go back. Skip, okay. Get elements. Okay. Skip. Okay. Since that. Okay. So first get this element and returns it, and then gets the next element. That's clever. That's very clever, actually. It's just basically repeating the same. You repeat the same thing. That's very good. Okay. That's pretty good. Okay, notice that both pop elements and skip pop elements use the private get elements method to obtain the array and to return. This prevents both methods from having to duplicate the same code sequence. Keep in mind that because get elements is private, it cannot be called by code outside in stack. So the usage is limited. Its use is limited to the default methods inside in stack. Because also because get elements uses the pop method to obtain stack elements, it will automatically call the implementation of pop provided by the in-stack implementation. Those get elements will work with any stack class that implements in stack. Okay. Although the private interface method is a feature that you will seldom need, in those cases in which you do need it, you will find it quite useful. Yeah. Yeah, basically. This is for abstraction, basically. It's to hide implementation. Yeah. Yeah, it absolutely makes sense. Final thoughts on packages and interfaces. Ooh, chapter 10, I guess. Although the examples we've included in this book do not make frequent use of packages or interfaces, both of these tools are an important part of the Java programming environment. Virtually all real programs that you write in Java will be contained within packages. A number will probably implement interfaces as well. It is important, therefore, that you be comfortable with their usage. Yep. Heck yeah. All right. So, chapter 10, exception handling. Okay, this is going to be pretty interesting. So, we're going to stop the video here. And we're just going to start recording the JavaFX book because I need to get that. And then we'll get back to the regular Java later in the evening so that we can start at the beginning of chapter 10. This is pretty good. Thank you. Later.